In the previous module, we introduced the notion of reliable delivery. We saw how the user agent sets a timer with each outgoing request and how, if a 100 trying response was not received before the timer expired, the request was retransmitted. In this module, we'll look more closely at retransmissions. In fact, by the time we're done, you should recognize the difference between initial and retransmitted requests, and you should know all about numbers of retransmissions and retransmission timers. If you have a user agent handy, why not make a call to a non-existent SIP address? Allow the call to time out, then look through the log for differences between initial and retransmitted requests. While you're at it, study the pattern of retransmissions, looking particularly at how many retransmissions there are and the time interval between them. Go ahead and press play when you're ready, and we'll compare notes. I've already entered a non-existent address here in my user agent, and I've also got a tail running on the user agent log so that we can see the SIP messages as they're added. Here we go, dial, and straight away messages appear in the log, more added all the time. There's another, and another, and so on. The time between each transmission's increasing with each newly transmitted request. Okay, the user agent's now timed out. So, differences between the initial transmission and the retransmissions. Did the CSEC change? CSEC1 invite, CSEC1 invite. No, the CSEC is the same. In fact, we know already the CSEC is a transaction counter, and retransmissions don't start new transactions. The call ID? No, they're the same. Just as we expect, seeing as all these requests are still part of the same call. So what has changed? Nothing. SIP makes no change between initial requests and any retransmitted requests. And this makes sense. If a downstream user agent receives a duplicate request, it knows it's a retransmission simply by comparing it to the previous request. There's no need to change any header content when transmitting a failed request. And the number of transmissions and time intervals, well, when sending the first request, the user agent sets the timer for half a second. If it expires then before receiving a 100 trying, the request is retransmitted a second time, and the timer is reset to 1 second, doubling the previous time. Then, after 1 second, the request is transmitted a third time, and so on and so on and so on, the timer doubling after each retransmission. So the total number of transmissions is 7, and the total time between first and last transmissions is 32 seconds. And that makes sense to me. Each retransmission gives another chance for the request to get through without flooding the network. Now, note that this retransmission pattern is for invite requests only. Other requests have a different pattern. You'll see that other requests are transmitted a total of 11 times over 32 seconds. Note how, to begin with, the timer doubles with each transmission, then changes and increments by 4 seconds after each transmission. Interesting. Now, it's important for you to know about retransmissions, particularly when searching through log files. Whenever we see copies of messages in a log, we know there was a delivery problem, either with the request or the response, and the timer expired and the request was retransmitted. So, reliable delivery and retransmissions. We've seen there is no difference between the initial and retransmitted request. No change in SIP message content. For invite requests, there are 7 transmissions altogether, spread over a period of 32 seconds. The timer starts at half a second, doubling with each retransmission. With non-invite requests, there are 11 transmissions, also over 32 seconds, although with a different timer pattern, doubling to begin with, then incrementing by 4.